Okay, this video is to kind of help you with your final assembly project here this week, the machinist clamp. And I'm giving you the two screws because they're a little complex. I mean, some of you could create them with no problems, but just because of the nature of the course being so fast-paced, I went ahead and created them for you, and I'm giving them to you for you to download. And you will create the other parts and then you'll assemble everything into a drawing. So here's one of the screws, um, and what you will do is you'll download them from Blackboard, create well, you'll have a Chapter 14 folder. You can put them in Chapter 14, or you can create another folder for just for the machinist clamp and save them in there. So download them and save them there. So I got pilot screw and the screw. Okay, you're going to create an assembly. Well, you're going to create the two jaws, which are different, and then the pin, which is identical. You create one pin and use it twice. But you're going to assemble this so that it is totally locked down. Nothing will move. Okay. Uh, Come on, computer. There we go. Okay, so it's totally locked down. Nothing will move. Um, and you can use offsets, mates. You can constrain work planes, axes planes together. Uh, Either way. Okay, this screw, the bottom of the end of the screw fits into the socket. The hole of this part, this one goes through both of those holes. These things are parallel to each other. And I used an offset here of 0.75 inches between those two. And that gives a pretty good representation, okay? All right, and so now you're going to create a drawing just like this one, okay? Very similar to the one that you created for the chapter exercise with the parts list. Now the parts list, depending upon how you saved your files, if you saved your files by the name, then you have to edit that information in the part file. And so we'll go into, I find it easy to just do it in the iProperties here because I know what I'm going to do. And so for my title, if I were creating a drawing of each individual part, this is what would show up as the name of that drawing, okay? But under project here for part number, I want you to number these things as the assignment number, which in this case is 14.35. That's my assembly, straight from the technical drawing textbook. And then a dash, and then each part number. And those are given to you in the sample that I will provide for you to see what the thing looks like. So rename this as the part number. And then under description, put the description of what it is. In this case, it's called a pilot screw. And it's made from a stock piece of metal that is 0.688 diameter by 3.88 long. That's my description of it. Okay. So when it shows up in the drawing, the part number is the part number that we would catalog it if we were a company manufacturing these things. The description is what it is. The material is what it's made out of. Now you will have to edit this because cold rolled steel is not listed in inventor's materials. Okay, so you'll have to edit this part of your title bar. Okay. Now on creating the drawing view, let me just pop in a new sheet. And this is a B-size sheet at a scale 1:1. Okay. let me pop a new sheet in, and I'll show you how to set this thing up. So I don't want that part file. I want the assembly. Okay, open. And I want the isometric view at a scale of 1 to 1. All right, so let's just do that. Now we see it looks kind of weird because we're not picking up a lot of information here. A lot of tangent edges of things are not showing up. So let's go into Edit View and under Display Options, Tangent Edges are on, and I'm going to turn that off just to show you what it changes. See, it changes all the fillets that we've created. So let's go back into that. We want to leave tangent edges on. Okay, because if not, we're missing some stuff there, okay? So let's go back and look again. Now we've got threaded features, so we want to turn on threads. Well, let's see what change that makes. Not a lot of change, okay? Because the way Inventor works with just a graphic of a thread, it's not going to show up in an isometric view like this. Now, if we had hidden lines, then those hidden lines would show up. Okay, so let's go back again. But we do want to have that turned on, okay? Now we want to turn on interference edges because we've got a couple of things that interfere. If you noticed in creating this shaft is larger diameter than this hole, which means when that thing goes in there, it is press fitted in and it will not come out. Okay. The threaded shafts are the screw part is actually larger than the hole. Just the nature of threads. If you looked at a nut and a bolt, you'll know as far as holes go, the screw is larger than the hole. So we want to turn on interference edges. Okay, and you notice that picked up those edges there. All right. Now to finalize what we want to make it look even better, more spiffy, back to component. I'm going to turn on shaded. So I want solid and shaded. Now we're picking up our screws, our threads, okay? And so this is a good looking representation. Now I changed the coloring on the jaws. I used gunmetal, excuse me, I believe, as an override on those. These were there's not a cold rolled steel. Let's see, what did I use? For material, and I set this in eye properties to start with, I used steel mild, and then I left it as semi-polished, okay, which was okay on that. So it kind of shows up looking nice, all right. And I think that pretty well covers the things I wanted to show you on this. You'll do the let me go back to sheet 1, and I'm going to provide you with a PDF of this, so you'll see exactly what it's supposed to look like. Numbering the things, filling the title block, and the parts list. So there you go. Now, when you do your pack and go, I'll cover pack and go in a separate video for the previous tutorial for chapter 14. But you'll pack it all up and submit it in Blackboard, and that will be that.